Hi folks, welcome to the channel. Today's video is on precision drilling in the home shop. What we're looking at here is a TV actuator project. It automatically lowers the TV for viewing when the TV is switched on. This is a great example of something that needs precision. You'll notice that there are two plates with cutouts and holes in both plates. If we expect both plates to line up, then we're going to have to be precise when machining. As you can see, these plates have undergone a lot of machining. All of this machining was done with 3D printed templates and a drill or a router. After machining, these plates were sent out for powder coating, but they didn't start out this way. They started out life as MIC6 aluminum cast plates. The top plate is 1/2 inch thick and the bottom plate is 3/8 inch thick. Here's what the raw cast plate looks like. Both plates were cut to the same dimensions, which is 25 inches by 16 inches. I measured both plates and they were the exact same size. Because the plates are the same size, we can use the corners of the plates as reference points. This makes it easier when designing the 3D printed templates. Here's the template used in the previous video. I've aligned the template to the part with M10 flathead cap screws. This is one alignment technique. This is the drill template that was used previously. I snazzed it up by marking the template with the drill sizes. On the flip side, the template extends down on two sides to catch the corner of the part. Using the corner as a reference ensures the holes are drilled precisely where they are needed. You might be thinking, hey, I've seen the previous video. We can use a template to drill holes too. I get it. That's true. However, using the template like this means it's really only a single-use template, because oftentimes drilling melts the template plastic. If you want to use the template more than once or create multiple parts, we need to do something differently. These are some of the 3D printed templates used in the TV actuator project. There is a lot going on in this photo. Let's start by identifying the drill bushings and drill bushing liners. The drill bushings fit into the drill bushing liners and are drilled to a specific drill size. They are what precisely guides the drill bit. The drill bushing liners get pressed into the 3D printed template and protects the template from melting from the heat generated by drilling. This approach takes care of the one-time use problem mentioned earlier. As far as templates, we have 3 different templates and 4 template inserts. First off, we have the template that drills the shaft ends. This slides over the end of the shaft and drills the 3 mounting holes. This drill bushing is sized to drill the tap size. This is where the precision comes in because the spacing of these 3 holes must line up with the 3D hole insert that is used on the movable plate. If you look carefully, the drill bushing used here is a bit larger. It's sized for the clearance hole. The next templates are the corner templates and the edge templates. These are used to drill the holes for the fixed and movable plates, and both have lips that extend down to catch the corner or edge. If you notice, the edge template has 2 notches, and its inserts each have a tab. This allows the insert to be repositioned by 45 degrees. We need 8 holes in the plate, and this approach lets us get by with using only 4 drill bushing liners. By the way, the drill bushings and drill bushing liners aren't cheap. Fortunately, after you're finished using the template, you can press out the drill bushing liners and use them again on the next project. We're going to look at using the edge template. But first, let me explain what we were trying to do here. This is one of the 2 ball screws used for the horizontal movement. The ball screw has 3D printed mounts that attach it to the fixed and movable plates. The mounts are attached with 8 socket head cap screws. The template is used to precisely locate and drill the clearance holes for the screws. For context, we're going to fast forward through a quick assembly of the ball screw and mounts. We're going to drill the clearance holes for the larger mount into the fixed plate. The edge template has 2 inserts. one to drill the holes and the second insert to route the hole for the ball screw mount. The previous video covered routing, so this video is going to focus on drilling only. The edge template catches the edge of the plate, which correctly positions the template in the X direction. However, we need to precisely locate the template in the Y direction as well. I'm measuring here to find out if the spacer centers the template. It turns out it does, so I have the flexibility of indexing the spacer from the top or the bottom and still end up with a centered spacer. If you're wondering why I'm using an edge template with a spacer, it's because a corner template would have been too big to print on my 3D printer. Let's get the insert installed and the template clamped down. As you can see, the insert fits snugly into the template. When designing this in Fusion 360, it's a bit of trial and error to get a snug fit. Typically, when parts fit together, you'll need to make one of the parts slightly smaller or larger. I have printed these templates with PETG carbon fiber, but PETG works as well. I chose PETG because it shrinks less than other filaments. Once the template is positioned, we get on to drilling the holes. By this point, there's really nothing to it. The drill bit fits tightly into the drill bushing, and the drill bushing slides in and out of the drill liner. This technique also ensures that the hole is drilled perpendicular to the part. Now we just have to rotate the insert. Notice the position of the Insert tab. It's too bad that the template needs to be removed to change the clocking of the insert. You see, every time we reclamp the template, we have a potential of it not getting repositioned properly. The use of the spacer helps minimize this problem, but it would be better if there was a way to change the inserts without moving the template. If you have an idea how this could be done, drop a comment. Now we just need to reclamp the template. Not too exciting, just more of the same. Notice how the insert clocking has been rotated by 45 degrees. This allows us to drill the second set of 4 holes, and as I mentioned earlier, only use 4 drill bushing liners instead of 8. Well, now it's just more of the same. Thanks for watching up to this point. I'd like to thank you and thank my subscribers. If you haven't subscribed and have found the video useful, please consider subscribing. It'll really help the channel out. Also, please leave a comment with questions or feedback. I'd like to hear from you. Stay tuned to the end for some outtake footage. But before we go, let's look at using the shaft template. You'll notice the tab sticking out of the template. I had planned on putting a bolt and nut through the tab to keep the template from moving while drilling the holes. As it turned out, I didn't need to do this, as the template didn't move. Well, that's it for the video. I hope you found it useful. Stay tuned for the outtake footage. Thanks for watching. Take care.
Because I was in the SpaceX video.
Yeah, you're right. Not too far out. There you go. Look at the camera. Wow. Do the other one.
This one's so much easier.
It is? Is the other one binding? A little bit?
Yeah. This one is sanded down a bit more.
Ah.
This one was just right.
Okay.
This one's just right, and this one is sanded down a little bit not.
Let's see. Let me see that. Oh yeah, it's a little bit easier. Not much, but a little bit. All right, thank you. Thank you for trying that.